Exercise 2.8. Using the graph of y equals x plus 1 over x squared, sketch the graph of y squared equals x plus 1 over x squared. So I've gone ahead and graphed y equals x plus 1 over x squared in Desmos, and our goal is to get the graph of y squared equals x plus 1 over x squared using the techniques that we talked about before. I've also graphed y equals square root of x, which we'll see comes in very handy. So first things first, as usual, we don't need to consider any negative values of the function. So essentially we just, for x less than, I guess, negative 1, we don't need to graph any values. So our function is only going to be defined for x greater than or equal to negative 1. Sorry, it's not a function actually, our mapping, I should say. Now, things we talked about in the section of our notes. If y was equal to 0 before, it's still going to be equal to 0. So we know our graph is going to go through this point. And the same if y was equal to 1 before, it's still going to be equal to 1. So we know our graph is going to go through this point. We also know that it should, when it's coming towards 0, clearly the tangent line in our original red graph doesn't have a gradient of 0. So we know that the tangent line in our new graph should have a gradient, or should be parallel to the y-axis. So that means it should kind of round off down here. And also we know that between 0 and 1, these y values in this mapping are going to be bigger than the y values in this mapping. So that gives us this kind of situation. So we should have something that looks like that for this little section here. And now for the case where the red y values are bigger than 1, that means that these blue y values are going to be smaller than the red y values. Clearly we have a vertical asymptote at x equals 0, and so similarly we're going to have the same vertical asymptote in the y squared equals x plus 1 over x squared graph. It's just that all the blue y values are going to be less than all the red y values. Alright, so that gives us this kind of shape here. Nice and wobbly. Actually, I think I'll redo that one. Try again. It's really hard not to make it wobbly on this computer. Alright, that's a bit better. Now, turning to this side of the graph, we can see there is a local minimum at this point. Now you can find what it is just by using differentiation, set it equal to 0. I'm just going to be lazy and check what it is on Desmos, and I can see that it's the point x equals 1.26, y equals 1.89. And the square root of 1.89 is 1.37, according to my calculator. And so that's going to be about, this is 1.5, so 1.37 should be about there. So that's going to be the minimum of my blue y squared graph. Okay, and since all these values are greater than 1, our y values are going to be less than them as well. So we're going to get this kind of shape here. And now the moment you've been waiting for. I bet you've been sitting there going, why on earth is there a green y equals square root of x graph that's been included here? Well, clearly this red y equals x plus 1 over x squared graph has an oblique asymptote y equals x. Oblique, L-I-Q-U-E, oblique asymptote y equals x. And so, but in this situation, for the blue graph, we're finding y squared equals this thing. And so, if the red graph gets closer and closer to y equals x, the blue graph should get closer and closer to y squared equals x. So in other words, it should get closer and closer for the positive y values to y equals square root of x. So that's what's going to happen over here. So we still have a minimum down at this point, and we're going to come up a little bit, but as x gets larger and larger, we should get closer and closer to this y equals square root of x graph. And then we're pretty much done. All we got to do now is reflect it about the x-axis. Just sketching this graph to make life slightly easier. Just reflecting the square root graph first to give myself something to aim for, even though it's pretty wobbly, but that's okay. So this is y equals negative square root of x. So then all we got to do is go ahead and reflect this blue graph. We should go through this point here, and then just kind of curve around like this. Can be a bit more accurate if you like, but I think that'll have to do. And then what? We're gonna go through. So this was 1.37, so we're gonna go through negative 1.37. So there's negative 1. So that should be about there. And then yeah, just reflect it. So this is gonna be a local maximum this time. This point. There you go. As it goes on, we should get closer and closer to the negative square root of x graph. And let's check how I did. So we got y equals x plus 1 over x squared here. So y squared equals x plus 1 over x squared. And so, yeah, pretty much y equals square root of x. Make it green. And yeah, we can see it's pretty much what it should be. Okay, so including this this curved part here, and so this line x equals negative 1 really should be tangent to the black curve at that point. Okay, so that'll do for this video.